Hello everyone, this is Levi Sheridan, and today I am making a video about the second prototype of my casted two-stroke engine project. The goal of this prototype was to make the improvements I thought I had to make after the first prototype. I picked up on a few issues and I wanted to make improvements on the design for the second prototype, and I did do that. I also added a flywheel as well as the output shaft here, so those are new things. I also took this prototype as an opportunity to integrate and test out the ignition system, which you can see here. And this ignition system is the ignition system I'll be using for the final design of the engine. And so far it works well, but I'll talk about all of those things. First, before I take apart the engine and talk about the actual design, I want to talk a little bit about the ignition system. So this is kind of like the brains of the ignition system. 6 to 12 volt DC input, 30,000 volt output. It's from CH Ignitions. It has a Hall effect sensor and a magnet located on the flywheel. And essentially what happens is when the magnet passes the Hall effect sensor here, signals triggered through the wire. The computer inside realizes that it needs to trigger the spark plug, which sits here. There's the spark plug, there's the spark plug cap. And basically every single time the magnet passes the Hall effect sensor, the computer triggers the spark plug, and that is great. It seems to work well, and I'll demonstrate that working in a little bit. But the challenge with this is basically having an infinitely adjustable or infinitely positionable magnet, because the location of the magnet has to be very precise, as the magnet is what triggers the spark plug. The spark has to be timed very precisely so that when the gases are fully compressed and the piston is at the correct position and all of the timing is set up, the spark plug has to go. So the way I've gone about doing that is basically by using a tapered or a wedge shaft and a screw to basically just hold the flywheel really tightly down against that wedge. And it just takes advantage of the mechanical advantage of the screw and the wedge and the tapered shaft, and works really well. So you can see there's no indexing, there's no fixed position for this. It's just a smooth tapered shaft. When I put it on, it sits freely, spins freely. And then basically, because it's a wedge, when I put the screw back on, it holds really tightly. It's a pretty long screw. I can tighten it down pretty well, and the flywheel holds its position very tightly. It's not going anywhere. Yeah, we'll see when the engine runs, but I can't really get it to slip. It's a very tight fit. I'm pretty sure this is how some things are actually done in the automotive industry, so it seems like it works well. It's something that people have done before, and the output shaft works the same way. There's the 6 screws along the outside of the output that allow you to clamp on whatever you want to clamp on the output, and then the center shaft is what is holding the output on to the crank rod. But basically, I'll demonstrate the spark plug. I'm actually going to take the spark plug out because it's such a small spark. It's such a small spark plug that you won't see or hear the spark from inside of the cylinder. It's actually so small, I don't know if you on the camera will be able to see it outside, but I'll turn on my power supply, which is hooked up to the main control box. And basically I'll just give this a spin. I'll try to get it close so you can see or hear it potentially. I can hear it, I don't know if you guys can. But it's definitely working. So essentially every single time the magnet passes the Hall effect sensor, there is a tiny little spark, and that's essentially what's gonna keep the engine running. I think that the means by which I have come up with a solution to make the magnet infinitely positionable, I think that will work well. The tapered shaft, I think that's not a bad idea. I think I've seen it on other parts before. So yeah, that's the ignition system. It's very simple, literally spark plug, Hall effect sensor, magnet, a power source, that's it. There's nothing fancy going on here. There is a tachometer RPM output, so it takes advantage of the Hall effect sensor, and just every single time the magnet passes, it will send out a signal, and you can use that with something like an Arduino or something to count the RPM. I don't know if I'll do that, but it's there if I want to. The Hall effect sensor is held on to the engine with some integrated clips I've included into the cooling fin area actually, and it works pretty well. They're very small, and actually they've broken on a few prototypes, but I think when they're made out of metal, it will hold up a lot better. But they're just it's kind of like little spring-loaded clips built straight into the design of the engine that hold the Hall effect sensor really well. But I am going to now kind of take apart some of this so we can talk about it, talk about the things I've changed, and just look at it and how it's assembled. So like you saw, the spark plug just goes in up the top. I used a tap. I don't intend to tap these plastic parts before I cast them. I'll cast them and then tap the metal parts, but I want to test the fit. So that's why I'm doing this. But basically I'll take off the cylinder. The cylinder is pretty much the exact same as the last cylinder from the first prototype. I don't think there's anything that's changed apart from the clips I added to hold on to the Hall effect sensor wire. But apart from that, everything printed really well the first time. There weren't any issues with it really, apart from the overhang of the cooling fins over the exhaust, which I'll show you on this one. It did print much better, which I had anticipated. So that's good. But overall, like the piston, I've never had, the cylinder, I haven't had problems with it. I did pick up a few things that were an issue with being printed on resin. First off, you can see the overhang on the blue one, on the PLA one. It's actually not so bad. I think I did take a drill to it though, so it does look better, but the overhang over those holes, it's much better, it's much cleaner. In general, everything is much cleaner, obviously. But a few issues I did pick up on are these holes. Something that is a nuance with FDM 3D printing is with the first layer, you have something called elephant footing, where the molten plastic is being pushed up against it, and kind of, the first layer is always a little bit thicker than all the other layers because it's being pushed against the build plate really tightly. And that is something that typically shouldn't happen with resin printers, but that was an issue for me where these holes, specifically the mounting holes that hold the cylinder onto the crankcase, some of them were filled in. I had to drill them out. I had to use a file to file them out. I also had to, I accidentally broke this one when I was doing it. So that's something I need to come up with a solution for. I printed this directly onto the build plate like that because I need this surface to be really smooth, and I can't really have any kind of support structures holding onto these fins because they're so thin and fragile, and this is honestly the best way to print it, but the issue is those holes get messed up. So does the cylinder. So the diameter of the cylinder at the bottom was like very slightly smaller, and I had to file, and it's something I have to work on, but it wasn't really an issue at the end. I just got to be more fragile and careful and get a drill bit maybe. That's the correct size. But the cylinder in general is really great. Like it fits the spark plug really well, and everything's really solid, so that's good. Nothing to really change apart from figuring out how to manufacture those parts properly, the holes. But now that we have that off, we can see this whole mechanism, it does work. As you can see, the piston's going in and out. When it's restricted by the cylinder, obviously it just goes straight up and down, but no, there's nothing restricting. It's plane of motion, but it's a very smooth motion. Like, it's very satisfying. There's very little friction. I think there's the only frictions from inside of the bearing. There's very little contacting parts. The only friction really is from the cylinder inside of, or the piston on the cylinder. And you can tell, like, when you put the cylinder on, it's definitely slightly harder to twist. But hopefully when they're metal and I can polish them, and I'm considering anodizing them as well, they hopefully will work better. But yeah, I mean, the piston is pretty much the same as the last one. One thing I found with the resin printing that's a little bit tricky is I print the piston like this, flat on the build plate, and one of the issues is this overhang surface is typically not very smooth. I think I probably just have to add some supports, which I didn't do. But in general, I'm really happy with this. Similar issue to with the first layer on this print. Because it was printed like this, there was a slight increase in a diameter of the very first layer of the piston head. I just took a little file to it, and that was not an issue. But in general, the piston's really great. I'm going to take off the flywheel now. I'm printing the flywheel and the output, as well as the crankshaft, out of resin actually right now. But I think there are definitely some arguments to be made to not cast this whole thing out of castable resin. Like, the castable resin is expensive, and it definitely has a use case, like for the cylinder, for the piston, for maybe the carburetor, because there are small moving parts or things that need to be really precise. But with things like the crankshaft, while it definitely does have to be precise, I think my FDM printer is capable, and there are definitely, in my opinion, more challenges and processes and difficulties in working with the resin printer. It's messy. You need to have the supports. I definitely am not as good as working with my resin printer as I am with my FDM printer, and I think for things like the crank rod possibly. Oh, I'm sorry, let me show you guys these really quickly before I continue to take it apart. It's just a flywheel magnet is just pressure fit in there. Those aren't through holes, so that's, I mean, not an issue, but it's pretty similar. You can see the tapered shaft on either end there. And they just sit on really well. It works well. But like I was saying, I don't have as much experience with, I'm actually gonna take off the carburetor first. I don't have as much experience with my resin printer as I do with my FDM printer. So it may be me or maybe the printer, I don't know. I think in the end, I haven't made the choice yet. I don't know if I will be printing all of the parts on my resin printer, or I will be printing a mix of them on my resin printer or my FDM printer. We'll see. But this is the carburetor. I made some tolerance improvements. That was one thing I found with the first prototype, is it was a very tight fit, and it does work really well. Now, I haven't gone ahead and added a handle yet. I think I'm just gonna have a round shaft and I don't know, super glue or do some kind of collar shaft for the handle of the air throttle. But I basically have added more tolerances. So here's the old one. It did work, but it required me to do some sanding and filing and whatnot, and it was all right. Like, it kind of worked well. But this one's just nicer. It's cleaner. Definitely works better. You can see I can twist the throttle body here, and just with my hand. And I had to do literally no finishing at all. Straight off the printer, I drop this in, and it spins freely like that. With the cap on, I also can kind of like push it around inside. So with the cap on, it's not gonna have extra friction that'll keep it from spinning. But apart from the tolerance improvements, it definitely printed well. No other changes. A few issues. I think the through holes on here didn't really print well, or I didn't do a good job of cleaning and getting the resin out before it cured. So that's something I'll have to practice or experiment with the manufacturing process. But like I said, in general, everything else with the throttle body printed really well. Like, this is just a very clean part. It looks very nice, no issues with it. So same case with this. The air channel printed well, but the hole for the needle didn't print too well. But I think with just a few more prototypes, I only made one of these, I'll be able to dial it in and get these made well. Moving on, we can take a look at, I guess, the crankcase. So the crankcase is pretty much the exact same as before. The only thing I changed was the spacing between the two bearings on either crankcase half. One of the issues with the first prototype was that when the crankcase was assembled, there was there was not enough room between the two bearings for the crank to actually fit. So it was difficult to close the two halves of the crankcase together. And when I was closed, I had trouble spinning the crankshaft. So I basically just moved them apart slightly, and that solved the issue. The crankcase closes really well now. Because this is printed on resin, the surfaces are incredibly smooth. Like, there are no layer lines like this. So if we look at the two crankcase halves from the FDM printer, I don't know if you guys can see, but there are definitely, this is the top layer, so they printed like this. But you can see there's remnants of the manufacturing process. You can see the nozzle path moving back and forth, and when they go together, it's not a smooth fit. The surfaces aren't smooth, and there's surface deformities, and it may look good, but microscopically it's not. Whereas with these prints, these crankcase halves, I'll remove the crankshaft and I'll talk about that, but these are incredibly smooth, like really, really great. It's just like I can feel how much better it is. They almost kind of like stick together. It's very smooth, and it's really great. So I'm really happy with that. One of my viewers suggested that when I manufacture these parts, I use I think it's called lapping compound. They use it to lap engine valves in their seats. It's like silicone carbide in a paste or something like that, and I basically will use that and just rub them together, and that will help smooth out the surfaces and make them more uniform, even more so, and hopefully I will get a good seal. And I was a little bit concerned after printing those and in general along this whole journey that this method of splitting the case wouldn't work too well, but it does seem like it's going to work well, which is exciting. Improvement on the seal between the FDM print and the resin print is evident, and I'm really happy with it. The bearings press fit really well into there. Same bearings. I had to take apart the old prototype just because the bearings are like $10 each, and I don't want to just keep buying them for every prototype. But yeah, those are the engine halves. Everything is the crankcase halves, and everything's really great about that. This was the part that I actually had the most trouble manufacturing. I took it through, I think, 4 design iterations. I'll put them in order, sequential order. I think, yeah, like it went like this, something like that. This one, I think this one went here. Yeah, it was like this. So actually, no, like this. There we go. So this was the first one. I printed them flat on the build plate like that. And you can see what I was talking about with the cylinder, how there's just these weird, like you can see this is what the final one looked like. It's like smooth and there's, I don't know what the hell is happening there, but it's not great. And I kind of made some improvements. I started using supports, and that definitely helped a little bit, but we can still see there are issues with that face on the print. I manually did supports and also lifted the prints up a little higher, and that made a little bit more of a difference. And then on my third one, I kind of just took those things, all of the things I picked up on those, and I really did a good job, I think, and hopefully these will work well. This surface is mostly cosmetic, but I like to make the things I make look nice. I wasn't happy with that, and I'm the one that's making these things, so if they're not how I want them to be, I'm the only person that can make them the way I want, and I'll do that if I want, and I'm happy with how they turned out. So those are the crankcase halves, very similar, as you can see, the old ones, practically identical, like I said. And then we have the crank. So the crank is, I mean, definitely an improvement on the old one. The old one didn't have the output shaft, so it was just like a test fit, just to make sure everything fit in terms of the connecting rod in the counterweights and all of that. But this improvement allowed me to incorporate the flywheel and the output shaft, which is obviously necessary. But in general, I like these. These are, like I said, something I'm considering just printing, because like these printed well. Like there are no issues with them. They're gonna work well. It's not like they're gonna be weaker because of the way I made the mold. The connecting rod's the same thing. Like I've printed them. I printed the connecting rod. And like you can see the same issue possibly with the first layer. I printed directly on the build plate like this, and I don't know, it's fine, but so is this, so we'll see. I also printed one of the crankshafts, or actually both of the crankshafts on my resin printer. I'm printing improved versions now, hopefully, but I mean, like they printed well. Like I said, like this is fine, but so are those. In fact, these actually did have a slight issue. The holes that I need to tap for the counterweight and the output shaft to go through, they didn't print well. So on my next version, I made the hole go all the way through. I don't know if you can see, that's actually what these are. The hole goes all the way through, and hopefully that will help with the resin printing. But there's also the artifacts of the support, and that's just something I don't have here. So there's an argument to be made, like I said, is there are benefits to printing with the resin printer, there are benefits to printing with the FDM printer, and I think just by prototyping, I'm picking up on what parts should be made with the resin printer, which parts should be made with the FDM printer, and in the end, I'll just have to make that decision. But I think with maybe 1 or 2 more prototypes, 1 or 2 more like complete full prototypes, I don't consider these to be prototypes of the whole engine, just individual parts. Once I've kind of put 1 more engine together, probably with the resin, fixed a few of the things that I've picked up with the resin printers, like reprinting this so the holes are printed well, making sure that the cylinder does have the correct diameter for the first layer, something with the piston, making sure the surface is flat on the piston, and kind of just seeing if I can actually fine tune the prints and get good quality prints of things like the crankshaft halves and whatnot. But in general, I'm really happy with how this is going. The ignition system works really well. Like I don't really have any issues with that, and it integrated well. The improvements I made on the first prototype really did help with this design. I was able to pick up on some of the nuances of the resin manufacturing process in terms of things I need to pick up on that I literally just mentioned. But in general, like I said, I'm very happy with this. I think the next prototype will kind of get me close to the finish line before I can go ahead and actually start to cast all these parts. I haven't been able to cast things recently because my crucible is completely shot. I'm scared that if I use it 1 or 2 more times, the metal will break through and mess up my furnace. So I have some more crucibles on the way, hopefully within the next week or so, and I'll be able to start actually making these parts. But in general, like this is almost everything. I really don't think there's much else to actually design. It's just small improvements here and there, fine-tuning the manufacturing process and getting it all together, and then seeing if the engine will run, and that will be really exciting. So I hope you enjoyed watching. I hope you learned something new. This is Levi Sheridan. Have a great day.